Hello everyone! Thank you for joining us today and welcome to the NativeScript release webinar. Today's webinar will be recorded and made available on YouTube after the event. My name is Ruslan and I'm the Product Marketing Manager for NativeScript. Before we get started, I'd like to note that this is the biggest release since the official product launch in March. Since then, we've seen tremendous support from the developer community, and our team has continued to enhance the product to make it the best native app development solution in the market. We'll be talking about some big features today, including cross-platform animations and Angular 2.0 support, but I'd also like to note the updated Getting Started guide. I think the new Getting Started guide makes it much easier to get started with NativeScript, so you might find it valuable. With that being said, I'd like to go over the agenda. John will give you an overview of the new features, TJ will talk about cross-platform animations and UI for NativeScript, and Sebastian will cover the Angular 2.0 support. We'll have some time at the end to answer your questions, so be sure to ask them. With that being said, I'd like to hand it over to John. John, take it away.
Thanks a lot. Hello everyone. It's my pleasure to walk you through some of the latest and greatest features we've added to NativeScript. We've got a lot to cover, so let's get started by talking about builds. In previous versions of NativeScript, the CLI used Ant to build projects when targeting Android. A few months ago, we started looking around for alternatives because we were finding it a bit cumbersome. It lacked a few features we wanted, and the fact that Android Studio was dropping support for Ant compelled us to explore other options, and ultimately we decided on Gradle. Moving to Gradle is a huge win when building NativeScript projects and provides a number of advantages over Ant. For example, the switch to Gradle dramatically improves build times. Previously, in NativeScript 1.2, building Hello World with Ant took about 24 seconds. With Gradle, we now get incremental builds out of the box. Building this same project takes only about 5 seconds, a near 5x performance improvement. Additionally, Gradle also offers seamless integration with current and future versions of native libraries, which we'll talk about later. Another big improvement we made in NativeScript was supporting the integration of COCOAPODS for iOS development. COCOAPODS is a dependency manager for Swift and Objective-C Cocoa projects and has over 10,000 libraries for you to use. With NativeScript 1.3, you can easily take a pod and use it as part of your NativeScript projects, working only with the CLI. There's no need to touch Xcode. I want to take a moment to talk about NPM, which NativeScript uses for managing plugin dependencies. If you worked with NativeScript before, I'm sure you're aware of the TNS modules folder. In previous versions of NativeScript, this folder was part of the project structure and contained the core modules we provided for things like the UI, network access, data binding, and so on. With NativeScript 1.3 and beyond, these core modules are now contained in a package called TNS Core Modules that's available through NPM. Switching to NPM provides controls over dependencies. This change gives us the ability to easily update these modules and gives you the ability to utilize NPM for its management capabilities. So when migrating your NativeScript apps to 1.3 and higher, one of the first things you can do now is delete the TNS modules folder and add this dependency reference. This will make your project structure cleaner and much more manageable. A question we're often asked is, what is your support for the latest version of iOS and/or Android? Now obviously this is important because both Apple and Google are iterating very quickly on their mobile platforms, and you want a framework that can keep up with the pace of innovation that's happening. With the latest version of NativeScript, you're covered, whether that's targeting the latest innovations in iOS 9 or Android Marshmallow, which just shipped. Oh, and that includes languages as well. With NativeScript, you can target TypeScript. In fact, the core modules are built with TypeScript. Anyway, that's enough slides. Let's get into some code. Recently, we published a Getting Started guide for NativeScript. This guide walks you through a series of steps to build Groceries, a groceries management app. I'll create a good chunk of that application in order to highlight some of the new features of NativeScript that I just talked about. Let's begin by jumping over to the terminal. Here, I'm going to be using the NativeScript CLI on macOS 10. However, I could just as easily do this with the command prompt on Windows and a shell on Linux. TNS, which stands for telerik-ui, create TNS groceries. The create command generates the project structure for my app and establishes dependencies. Speaking of which, here is my package.json file. Looking quickly at this file, you'll notice that we now list TNS core modules as a dependency. This gets back to what I said earlier about our commitment to using NPM. You can now utilize the core modules or other plugins as dependencies with NativeScript 1.3 and higher. This is really nice because the list of community plugins is growing rapidly. You can quickly integrate a plugin into your NativeScript apps through the CLI. Here's how it works. On the command line, simply type npm install and then the name of the plugin. For example, here's one I wrote earlier called NativeScript Sound, which you can use to play audio in your NativeScript apps on both Android and iOS. Executing this command will go off to npm, download the plugin, and integrate it into your project. Let's jump in with Visual Studio Code. Expanding the app folder, let's bring up the UI for the main page. This is the stock app that's generated through the CLI when you create a new project. Let's see it in the emulator. To do this, I'll execute the live sync command so I can quickly see the changes made to my app when I modify the underlying code or markup. It's important to note that my app is running on iOS 9 in the simulator. This app showcases the data binding capabilities of NativeScript, but as you'll see, there's a whole lot more we can do. Let's bring up the Android emulator I have running on Marshmallow. I'll go ahead and build the same project for Android. Here, the NativeScript CLI automatically adds Android as a target platform and copies over the project template for the build. The CLI also generates a Gradle build file for you and kicks off the build. You don't need to run Android Studio. And furthermore, we provide integrations into this build file through the CLI. This is new in NativeScript. Previously, we used Ant, but it was difficult to manage and evolve over time. With Gradle, things are a lot nicer. So for example, our build definitions are easier to maintain, we now have faster build times through incremental builds, and there's a lot better dependency management as well. If you jump into the Android directory for your project, there you'll find the build file. If I wanted to, I could modify it to incorporate dependencies. However, the NativeScript CLI will manage a lot of these changes for you. Let's get the application installed on Android by issuing the live sync command. Okay, now my app is running on both iOS and Android. Let's define an action bar. This is where you'll place items like the title's view and navigation buttons for navigating forwards and backwards. Here, I'm using a set of code snippets for Visual Studio Code that are available up on GitHub. There are snippets as well for other IDEs such as Sublime Text. I'll change the title to Groceries. Next, I'll replace the stack layout with a grid layout since I'll be looking to position elements via row-column placement. Now let's add a list view, which lets me display a list of things on the screen, which is exactly what I need for showing a list of groceries. This is the NativeScript's built-in list view, not the list view that's provided in the telerik-ui for NativeScript. That list view has a great deal of functionality and is incredibly powerful. TJ will be covering this after me. Here, I'll change the list of items to point to a view model property called grocery list. I'll create this shortly. Next, I'll delete the event handlers here since I don't need them yet. And finally, I'll define a list view template to simply output the name of every grocery in my list. Now, because I want users to be able to enter groceries as they're shopping, I'm going to go ahead and add a text field and a button as well. For the sake of time, I'll simplify this example by deleting the predefined view model in main-viewModel.js and override the underlying code for the main page. I'll also override some of the styles that we've applied for this app. As you know, NativeScript supports a subset of CSS which enables you to style native UI elements as if they were DOM elements in a browser. That's looking a little bit better. Of course, Live Sync enables this fast iteration, going from your application code and markup to native elements on a device or simulator. Now that we have the basic structure for our application built, let's explore how to incorporate it with some backend data. Specifically, I'm going to use Firebase. Firebase is a real-time database from Google. It provides notifications of CRUD updates through its native SDKs for iOS and Android. There's also a JavaScript-based SDK. However, that assumes a browser context. Because with NativeScript we're targeting native UI elements, we're going to target the iOS and Android SDKs instead. With NativeScript, I can now incorporate native libraries through a number of ways. More recently, however, we've added support for COCOAPODS. Let me show you how this works. I'll start by creating a project called NativeScript Firebase. This project will serve as a plugin that I will consume within my groceries app. Now, I'll define a pod file and include a reference to the Firebase pod that's hosted up on COCOAPODS. This is the official pod for Firebase. Believe it or not, that's all I have to do to get integration working with the native iOS library. Let's now integrate the library for Android. This is made available from the Firebase team as a jar file. However, it's worth noting that we also support AARs. For Firebase, I'll add an Android manifest.xml file. This lists the permissions that my plugin will need. In this case, the plugin requires internet access. Once this is done, I have everything in place for both iOS and Android. Let's now go ahead and use this plugin in our app. Switching back to our other directory, I'll do this by adding the plugin to my project via the CLI. Now that this process is complete, the last step is to start targeting the APIs exposed through Firebase. For the purposes of time, I've gone ahead and done this already. And now let's see what's happening on the iOS side. In order to target Firebase, I need to connect to its remote service that hosts my data. This is the endpoint here. Once connected, Firebase will notify my application whenever changes are made to the backend data. I can respond to these changes by updating the view model I have exposed through my front end. Additionally, any changes made to my view model I can propagate back to Firebase easily. In both cases, you can see just how easy it is for me to consume the native APIs exposed through the pod file that the Firebase team has provided. It's that easy. Let's now switch over to the Android side of the house. The code here looks somewhat the same. Remember that I'm using the jar file that exposes the Firebase SDK for Android. Again, I've registered against the service, providing context, and now consuming its APIs. Read and write operations are supported going in both directions. When I now generate a build, you'll notice the CLI will automatically incorporate the pod file and jar file for iOS and Android respectively. That's all I need to do. If we now run the app, we can see that we can add new items to our grocery list. When added, these items are created on the Firebase side, which we can view through the web client that Firebase provides. Furthermore, changes I make on the back end are sent as real-time updates to my app. This includes new items, changes, deletes, and so on. In the case of both iOS and Android, my NativeScript app is incorporating the native SDKs to support this scenario. And so there you have it, lots of great features that have been added to this latest release of NativeScript. That's about all the time I have to cover just a few of them, but at this point, I'd like to turn things over to TJ, who will walk you through some of the other enhancements we've added. TJ, over to you.
Awesome, thanks John. My name is TJ VanToll, and I'm going to build upon what John just showed to introduce two new NativeScript features that we think are pretty cool. I'll start with animations, which landed in our recent 1.3 release and lets you apply a wide variety of effects to your interfaces, so opacity changes, translations, rotations, and that sort of thing, all using a very simple JavaScript API. The second thing I'm going to show is the list view control that we just added to our UI for NativeScript control suite. The new list view supports building some really rich, really powerful UIs, lots of cool features in there. And again, you get to use this control with the simple and easy to use APIs that you've come to expect from NativeScript. Now, like John, I like to stick to demos rather than slides, so I'm going to move over a desktop here where I have a really basic demo set up to show off how NativeScript animations work. This page is really simple. I just have an action bar that shows the title of this little demo, and I have an image that's positioned in the center of the screen here. The image has an ID of icon, and I'm going to use that ID to actually get a reference to this icon in my JavaScript code behind file. And the easiest way to use NativeScript's new animation APIs is just to call the animate method that now all UI components have. So I get a reference to the icon, and then I can just call animate. In this case, I'm passing the animate method in opacity, so I'm saying basically fade this element away. And I'm passing it a duration, so I'm telling it to do that fade over 3 seconds. There are a number of additional options I can pass, so instead of opacity, I could pass a scale here. This will essentially say double the size of this on the X and Y axis, so you'll see the grocery basket blow up and get big here. I could do rotation, so rotating 180 degrees, as you might expect, is going to flip this grocery basket over. I can combine these properties, so I could say rotate this grocery basket and also change the opacity to 0, so basically flip it and fade it away at the same time. But the real power of these APIs is in their composable nature. So not only can you call animate, which is just a simple JavaScript API here, but animate actually returns a JavaScript promise. Now what that means is I can actually chain this animate calls with subsequent animate calls if I wanted to do a more complex animation. So in this case, I'm going to animate the icon. I'm going to scale it again, so I'm going to make the icon big. Then I'll flip it over 180 degrees, which you'll see right there. And then I'll actually translate the icon or move it, in this case on its y-axis, and a positive value will move it down, and that's why the grocery basket went off the screen. Now, as you might imagine, the composable nature of the NativeScript Animations APIs means that you can do a whole lot in a small amount of code. However, I want to show at least one sort of practical example of using these animations, because after all, just because you can make a grocery basket sort of bounce around the screen doesn't necessarily mean that that's what you should be doing as part of your next app. So to do that, I'm going to return back to groceries, which I've polished up a little bit. I'm also going to bring in my iOS app, or my iOS simulator here, so we can see these things side by side. Now to get back to groceries, I got to switch my starting view back to groceries login screen here. And what I'm going to show is I actually want to optimize this list view. You can see that currently this list view just sort of pops into place when the data loads, which is fine, but what I want to do is add a small little fade-in effect, mostly because it'll help draw the user's eyes to this data as it comes in and make this app look a little bit nicer. So I'm going to open the code behind file that actually controls this view that you're seeing here. Now the code that actually loads this data is down here. This is the loaded event for this page, and a little further down you'll see that I first show the page loading indicator or the activity indicator. Then I'm going to actually grab this data from my backend database, and then this method returns a promise. So when that completes, all I'm doing at the moment is just hiding the page loading indicator. Now I have a reference to the list view up here, this grocery list element reference. So what I'm going to do is I'm going to take that reference and, using some code that we just saw earlier, just call animate on it. And in this case, I'm going to change its opacity to 1, or basically make it display. Now in this case, this actually isn't going to do anything yet. You'll see the grocery list still pops into place because I'm changing the opacity from 1 to 1, because the opacity of an element is 1 by default so that it shows up on the screen. So I have to do one more thing. I have to change the starting value of this element's opacity. This grocery list reference I have in CSS here is actually the same as this grocery list element here. So I'm going to change its opacity to 0. And with that change in place, we'll actually try this out, sign in, and you can see that very slight fade-in effect that's now in place. This is a simple example, but with animations, you want to be careful not to do things that are too crazy or get in the user's way too much. For instance, I could bump this animation up to, say, 3 seconds, but if I do that, after I load this page here, you can see it's sort of annoying to have to wait so long to get your data. And I've seen good best practices before that say, generally speaking, you shouldn't have an animation that lasts more than, say, like a half second or a second. And personally, a half second feels about right to me. Hopefully this gives you somewhat of an idea of the sort of thing that you can accomplish with NativeScript animations. We've had people in the community build animated menus, and custom splash screens, and all sorts of fun things. So I encourage you to give these APIs a try for yourself and see what you can do. Have some fun. If you're looking for further docs on this, if you go to docs.nativescript.org, there's a full animation page. It's top level in the docs right here that goes through in pretty good detail the sort of things you can do, the sort of APIs that are sort of outside of the scope that I had a chance to show today. The next thing I want to show is the new list view control. But before digging into the code, I want to quickly go over what telerik-ui for NativeScript is for anyone that didn't attend our previous NativeScript webinar. First and foremost, telerik-ui for NativeScript is a NativeScript plugin. So you install it using the same TNS plugin add command you use to install any NativeScript plugin. The product is currently available as a free preview release, which means that anyone can use all the controls in any of the apps they're developing. When we move the product out of its preview state, though, we will be including some of the controls at a paid tier, and that includes the new list view control that I'm about to show. And that's really due to the sheer breadth of the functionality that some of these controls offer, like the chart and like the list view. So let's take a look at what the list view can do. As with the animation example, I've thrown together a simple little example just to show off the basics of the list view. Now in this case, I'm still using the built-in list view that may be like one you're using in your NativeScript apps today. All I'm doing is tying this to a simple observable array, just a number list. This number list is an observable array that I'm just in my loaded function filling with 1,000 random numbers. You can see my call to math.random here, which just gives me a decent data set that I can toss on the screen and mess around with. Now to switch from the built-in list view to the list view in UI for NativeScript, all I have to do is point my list view at the location of the new control, which in this case I already have a reference through this XML namespace here. So I'll grab this list view here and I'm going to switch over to the namespaced version. The only other thing I need to do is tell the new list view control which layout I want to use. The new list view contains 3 different layout mechanisms. I'll start with a simple linear layout just so you can see that it's basically a direct equivalent of what we already have. But with this setup out of the place, now I can start to use some of the really cool features that this control has built in. To start, a pretty common requirement or a pretty common thing people need to do in their mobile apps is actually allow people to reorder items in a list. So if I want to enable that behavior, all I need to do with this control is pass the cell reorder attribute and set that to true. You can see on iOS, I get these little icons built in that allow me to refresh these items in the list. Oops. And on Android as well, I can do a long press and hold, as that's sort of the Android convention for sorting, to sort these elements in the list as well. Another common requirement is pull to refresh, which is also extremely easy to implement with these controls. All I have to do is pass 2 attributes. The first is set this pull to refresh attribute to true. And what that'll do is that'll enable this little animation when I do a pull to refresh on these libraries, or on these list views. The second thing I need to do is implement this should refresh on pull event. And I'll head over to my code behind file to show an implementation of this here. Now, a should refresh on pull event handler has to do 2 things. The first thing is it has to tell NativeScript whether to sort of continue to show this animation that you see on the top of the screen here. And the second thing it has to do is call this did refresh on pull method when all processing is done. Now in a more realistic scenario, and I'll show one momentarily, at this point I would go to my backend database and sort of retrieve some new data. But for the purposes of demonstration, all I'm doing here is saying just wait around 3 seconds and then add 3 new items to the list. Push through 3 new things into the array, and then call did refresh on pull to sort of tell NativeScript to take down the animation. And you can see what that looks like on iOS. I'll push this on Android as well, wait 3 seconds, and then 3 new items appear on the top of the list. Hopefully this gives you an idea of just how much power you have with this new list view control and just how much you can accomplish in a small amount of code. But we're just scratching the surface here. To start, there are many different ways that you can actually lay out your list views on the screen. This was just a basic linear layout that I'm showing here, so I want to show at least one example of a more complex layout. So I'm going to switch over to a grid here because the grid layout is pretty fun to play with. This example uses basically an identical backend. I'm again just taking a number list and filling it with a bunch of random numbers so I have some data here, but you can tell something is different by just how these items are arranged on the screen. By configuring a few attributes, in this case I'm telling the list view to use a grid layout here, I have all sorts of power over how I can control what these things look like. And in this case, I still have cell reorder equals true, so I can additionally do this and still get sort of the fun, oops, I gotta do a long press, do some of the fun sorting that I showed earlier. It's especially fun on iOS because iOS has a pretty cool animation when you do this. With any of these controls, linear or grid, you're also not limited to vertical scrolling. That just happens to be the default. You can also change this thing to use horizontal scrolling, and I'm also going to include a little height here to sort of restrict this UI. And with just that little configuration change, I'm now able to scroll these lists horizontally. This UI actually feels, it's becoming more common in apps. I see this in a lot of apps. Netflix's iOS app I know does this, for instance. I think their Android app does as well. Finally, before I run out of time today, I want to show how you can incorporate this list view into a more realistic scenario. So I'm going to switch back to groceries to show how to implement it there. So to do that, I'm going to switch my starting page back to the login page. Oops. To switch back to groceries, I'll open back up my list files here. Now I've already switched the list view in this app to be one of the new list view controls. I'll add a little more screen real estate here. I'm using a linear layout as well, just because that's what groceries happens to use, but I'm actually not using any of the new list view features yet, so that's what I want to do now. The first thing I'll do is add a fully functional pull to refresh handler, so let's paste in those same attributes I looked at before. Set pull to refresh to true to turn on the pull to refresh functionality, and then implement one of these should refresh on pull events, which I actually already have in my JavaScript file. I actually love how simple this event handler is because it shows just how much you can accomplish in a small amount of code. Essentially, to implement this pull to refresh handler, all I have to do is tell NativeScript to continue showing the animation until I'm done, then call my backend. GroceriesList.load here actually invokes my backend service, will get me back my data and sort of manipulate my data model to show those elements on the screen. And then, because this returns a promise, I come back and tell the list view I'm done by calling did refresh on pull. And the result of this is pretty cool. So I'm going to go ahead and log in on iOS and Android as well. Now you can see right now my grocery list is kind of mundane. I just have some basic fruits and vegetables on my list. So I want to get something more fun. I'm pretty excited about Microsoft's new Surface Book. So I'm going to go ahead and add that to my list. Now because I have pull to refresh implemented here, all I have to do on Android is come back over here, do a quick pull to refresh, and the Surface Book appears on the bottom of my list. Now after I pick up that Surface Book, I'll go ahead and mark it off my list, which means I can come back to iOS here, pull to refresh, and you can see I can instantly keep my applications in sync, which I think is pretty cool. Alright, I'm running low on time. There's one last feature I want to show, and that's the concept of swipe cells. If you're an iOS user, you're probably familiar with swipe cells, and what I'm talking about is when you swipe a list item one side or the other to reveal some functionality. A lot of the built-in iOS apps use that, and some apps use it on Android as well. What the list view control does is provide an abstracted API for iOS and Android that's really quite easy to use, like the other attributes we've already seen today. So to use this, I'm going to head back into my XML file and paste in two new attributes. The format will feel fairly familiar here. Again, I have a Boolean attribute to actually turn this feature on to tell the list view control I want to use swipe cells. And then I have a single event handler to sort of define how it works. In this case, I define things like limits, like how far I want the user to be able to swipe over before a button shows on both sides, and sort of thresholds and things like that. Some basic configuration. But my favorite API, or my favorite part of this API, is how you provide the actual buttons or the things that live behind this list view. To do so, all you have to do is include this item swipe template. Now, this looks like a decent amount of code, but it's really quite simple. You may know that to lay out a list item in a NativeScript app, you need to provide an item template. And in this case, that's controlling what each individual item in this list looks like. So you have an image that actually controls the check mark, and then a label that controls this text that displays here. The item swipe template works the same. It's actually taking up the exact same real estate here, but it's living behind each individual item template. Now in this case, what I'm doing is I'm configuring two images. I'm going to put a little green done button on the left hand side and use that to control this checkbox here. And on the right hand side, I'm going to put a red delete button, or a button that'll actually let me remove items from this list. In the middle, I'm just placing a little placeholder because the user will actually never see that content that lives in the middle. With that in place, I'll go ahead and save that, and we'll go back to the applications here. And you can see that now I'm able to swipe these apps left and right, or these list items left and right. I'll show it on Android as well. Swipe left and swipe right to actually implement this functionality. As with all these features, this behavior is incredibly configurable. I could make this swipe actually complete the action, so instead of forcing the user to click a button here, I could actually just make the swipe gesture itself do the delete in this case, or I could force the user to click a button as I've implemented here. The decision is sort of up to you and how you configure these APIs. With that in mind, I encourage you to check out the telerik-ui for NativeScript docs in the code up on NPM to get a sense of just what you can accomplish with these controls more than I showed today. With that, I'm going to turn things over to my colleague Sebastian, who's going to be talking about the latest with our Angular integrations. Sebastian?
Thanks, TJ. This was great. My name is Sebastian Witalec, and I would like to talk to you about our Angular 2 integration with NativeScript. But let me start with explaining how Angular 2 actually works. First, we start with a markup language with which you define what should go into the UI. Then we have DOM adapter, which parses the markup into a node tree. Then there's a compiler that takes the node tree and compiles it into a set of proto-views. And here's the interesting thing. The proto-views take care of binding property changes and events defined in the markup. And the beauty of Angular 2 is that All these steps so far are completely platform agnostic, which means that this process could potentially work with anything from a web app to a smart fridge, assuming it can run JavaScript. All we need is a platform-specific renderer, which takes the proto-view and creates a platform-specific visual tree. And the renderer is responsible for propagating the events and property changes down the visual tree, and in reverse, when an event is raised in the UI, the renderer will pass it up to the proto-views. So the way Angular 2 is designed gave us a great opportunity to combine it with NativeScript to build amazing mobile application. But we had to do few things in order for it to happen. First, we decided to use HTML as the markup language. We did that to take advantage of an existing DOM adapter, which is Parse5, which saved us a lot of time and allowed us to focus our efforts in other areas. And because of the way Angular 2 is designed, we didn't have to do anything to the compiler or the compiled proto-views. But the real work was in implementing our own renderer, which generates a native visual tree and is capable of propagating property changes and events between the proto-views and the native visual tree. So having explained how this all works, it should be easy to answer the big why question. First, we wanted to provide the same experience of building mobile apps as it is for building web apps, by allowing Angular 2 developers to reuse their skills. And because of the way Angular 2 is designed, you could even dare to build mobile apps and web apps with a single project. Obviously, the big difference will be in the UI design of the views, where in most cases you have to develop the UI for mobile and web apps separately. But the business logic that controls the flow of the app can be shared. And even when it comes to building functionality that is implemented differently on mobile and web. For example, let's have a look at the HTTP module in NativeScript. So depending which platform we are targeting, all code that use the modules gets translated in either iOS or Android specific calls, which then executes in the apps. But now let's have a look at even bigger picture. When we add Angular 2 to the equation, we can use an Angular 2 HTTP module, which will translate into either NativeScript code for mobile apps or browser specific, resulting in AJAX calls. Just think about it. Now you can build the business logic for both the web and mobile apps in one go, and let Angular 2 take care of the differences. To do that, you can use Angular 2 concepts and syntax, which allow you to do stuff like attribute and event binding, or you can set up conditions in order to either show or hide a component, or even have conditional styling. So let me show you a couple of examples, but there's one small warning. Both Angular 2 and our integration with it are currently in alpha stage. So let's start with creating a hello world example. So in order to create a hello world, what we need is create a page that is basically our hello world page module, which contains a template, and the template contains a stack layout and a label that says hello world. And in order to actually add that to our project, from our main page, we have to import our hello page module. And then when we call NativeScript bootstrap, which is an Angular 2 call, and then pass in the module as an attribute, then basically that will load the application with the module itself as the first thing. And now you can see on the right hand side it says hello world. And probably you can't see it very well. So what we can do is basically apply a bit of CSS. So I already have a class called big, which sets the font size to 30. So let me do that, and I can say class equals big. I can save that. However, there's one more thing that I probably missed to tell you before. All Angular 2 code that you'll be writing uses TypeScript. So in order for it to actually work with NativeScript, what we have to do is call grunt app, which will compile TypeScript into JavaScript. And then once it's compiled, LiveSync will pick up the changes and refresh our application. And now we can see our hello world a little bit bigger. There's another thing that we can do is basically say, hey, I don't want to hard code the hello world message, but I would actually want to have an attribute So let's say string, message string, and from here I can say hello from Angular 2. And then what I can do next is basically add a square brackets around text property, which basically means I want to bind it to an attribute. And now I can say bind it to message. Let me save that and run grunt. And after it refreshes, the new message should actually say hello from Angular 2. Here it is. Some other things we can do is, let's imagine we had a warning flag, which would be a warning boolean. Let's set it to true. And I'm going to show you basically a bit of conditional styling. So I can do square brackets class dot, and here's the other style I want to use, which is warning label. Let me assign it here. And what I want to do is say basically this. I want to apply warning label style when warning is true. So I can save that and run grunt. And after this refreshes, because warning is already set to true, we should have both the big and warning label styles applied. And now we could see our message is nice and orange. So what next we can do is, let's create a function that we can call it switch warning state. This function will basically say I want to take warning and set it to the opposite value. And so what this gives us is basically we can add now a button that we can say, okay, tap me. And now we can basically add a tap event binding. So by just wrapping tap with brackets, I can now say, okay, on tap, I want you to do this. So on tap, I want you to call switch warning state, and I'm gonna call it, and let's close the button. Save that and run grunt. And then after this refreshes, we should get a button which should do two things. One, it should call switch warning state, and then it should actually alternate warning from true to false, but this should result in a warning label to be applied or removed. And there you go, the CSS is actually changing. One more thing we can do is I want to show you how ngIf works. So if we had another label that we only want to show when the warning is actually true, so I can say ngIf equals, again, you can say warning, and the text value would be panic, run for your life. Let me close that, save and run grunt. And now after this refreshes, our app should have a label which only shows when warning is true. And let me keep tap in and out, and the label appears and disappears. I know it's not particularly amazing example that I built, but it should give you an idea of, you know, like how you bind to properties, how to set up conditional styling, or how can you actually bind to events with Angular 2 syntax. The big difference, I guess, between what you would expect from Angular 2 for web and for mobile is actually the types of markup that we're using. So basically there is no divs, and because there's no divs in NativeScript itself or native APIs, So we have to use stack layouts, we have to use labels and buttons, which are pretty much NativeScript specific. Let me show you a couple of other examples. So another example that I have here is an authentication page. So let me switch to it first so that you see what I'm after. Save that and grant it. And now we have a new example. So this example is spread across two files. So first we have a model where we have our authentication class. So in here we have stuff like the username, password, a state where we logged in or not, and a message prompt. There's other things like in a constructor we create one account, and as well we have a login function, we have a logout function, and then one to register a new user. And having created a model like that, then I can go and create a page. So let me start from the bottom. So for our page module, what we do is create a authentication page class. Our authentication module itself, it's gonna be here as an attribute. And then basically what we're doing in the constructor, we're creating a new instance of authentication. And how does the page know about the authentication itself? It basically, we call import, and then specify where the module is that we want to load. And then by saying authentication, this is how we say we want to use this class in here. We have in here a couple of other things. So we have onLogin tab, which basically expects a UI component to be passed in as well as username and password, and then in here we will take it and put it to lowercase for both username and password, just for simplicity. But as well, what we're doing is basically saying I want to go to authentication and call login, and if something goes wrong, I want to call animate failed action, which surprise is actually using NativeScript animation module. So what I'm gonna do here is just run animation that moves our page by 10 pixels to the right 5 times really fast, so it will give us an effect of like a shaking screen. So once we have this code behind for our page, what I can do is start building our UI. So first we have a stack layout which covers the whole page. We have one label which takes and displays the authentication message. So you remember the square brackets, so that's how we do the binding. And then we have two stack layouts. We have one stack layout with ngIf that says if authentication logged in is false, then show. And then we have another which says I want to show this one when authentication is actually logged in. So we either see one stack layout or the other. So whenever we're not logged in, we should have a couple of text fields. So we have one for username and password, and then we have a couple of buttons, one for login, one for register. Let me explain a few things in this code here. One thing that we're doing is we want to bind the text attribute to the authentication username. We provide a hint, but we have this funny thing which is says hash my login, and the same thing for the password text box. We have hash my password. So what we use it for is when you tap on the button. So what I can do is actually say get my login.text. So this my login points me to this particular text field, and similarly for my password.text, I can actually go and extract the text attribute from my password, because by default Angular 2 doesn't use two-way bindings. In order to use two-way bindings, there's another way of doing that, which is not implemented in NativeScript just yet. So basically, like the same idea is on register tab. When you tap this button, then we take in and retrieving my login.text and as well my password.text. But as well, what we're doing is our main page stack layout has the login layout. So we retrieving it and we passing it into our onRegister function. So when you actually run onRegister, you see the form is the thing that is passed in to animate failed action when something goes wrong. So let me show you that in action. So if I go Seba and then press login, the screen shakes because the password was wrong. But if I add WITA and press login, it takes us to another page, which is for this ngIf. And if I press log out or tap log out, then it takes us back to the very first page. And where to go next? So if you would like to try it for yourself, you could go to github.com/nativescript/sampleng2do-mvc, which is the base example that was created by Hristo Deshev, or you could go to any of these two examples that I created. So one is an up and down game that I created the other day, or the login example. And that's pretty much it from me. Over to you, TJ.
Thank you, Sebastian. Alright everyone, we're going to be answering your questions pretty soon, but before we do that, I'd like to highlight a couple things. First of all, take a look at our new plugins. We have a cool new maps and a sound plugin that would be great to include in your applications. Also, App Builder now supports NativeScript plugins, so be sure to check out App Builder. You might be asking, what is next on the roadmap? Here are a couple things. We're going to continue enhancing UI for NativeScript. We have a calendar widget on the way. We're going to improve Angular 2.0 support. And we're going to enhance the development experience even further by adding new installation procedure for dependencies, improved App Inspector for iOS, and bug fixes and improved documentation. To stay up to date with the latest news and updates, be sure to follow us on Twitter.